All right, as more people join, I have a little trivia for you. What percentage of enterprise data is estimated to be unstructured? What do you think? Is it 40%, 20%, 60, 80%? What do you think? Let us know in the chat. 80%? I see 60%. It's kind of like an auction going up, going up. Right. So we have a few answers. 80% or even more than that is the actual answer. I think it was Gartner who did the research on that, and that was their estimate. So that's what we see as well in the field. And so unstructured data has become increasingly more and more important over the past couple of years with the Gen AI and LLM revolution that we're seeing everywhere. All right. It's been 2 minutes, and so we already have some attendees. If somebody's late, then they're late. Let's start the webinar, and let's start with some introductions. So today, this webinar is hosted by myself. My name is Maria Halasova. I'm a head of developer relations at Unstructured, but I will be playing more of a supportive role today. Our main star is Daniel Schaufield. Daniel is a principal solutions architect at Unstructured. He has worked with Fortune 500 companies to design and scale AI systems based on unstructured data. And Daniel brings more than a decade of experience in software architecture, data science, AI. So we're excited to have Daniel today to talk about data quality. And let's talk about the agenda for today for just a quick minute. So we'll start with a little bit of context, which is our open source origins. We'll look back at how Unstructured open source library came together, how it fit into the whole rise of LLMs, and why it ended up being used in so many RAG systems. And then we'll move to the post-VLM era and ask a question we're continuously working through. How do we actually solve document transformation at the highest levels of quality? And finally, we'll close by answering the question of how we are building for tomorrow. This is going to be a sneak peek at what our team is focusing on next and some of the directions that we think will matter most going forward. Now, a little bit of housekeeping. Obviously, you can drop your questions in the chat, and we'd love to see you asking us questions and sharing your comments and your experiences in the chat. But if you want your question to be answered live at the end of the webinar, you should drop it into the questions box. You can see the Q&A box in your panel at the bottom of the Zoom UI. We will send you the recording of this webinar in a day or two, as well as the slides. So if you missed something, if you had to step away, you can get back to it and rewatch it. And if you're interested in exploring Unstructured, learning more about it, scheduling a POC, you can always reach out to us later, and we will be happy to guide you through a POC. And so with that, we can actually move on to the meat of the webinar, and I'm going to hand it over to Daniel.
Thanks, Maria. Hello, everyone, and thank you for joining today. As Maria shared, my name is Daniel Schofield. I'm a principal solutions architect here at Unstructured and have been working with the company now for 18 months, which is interestingly around half of its life. And just for some context setting, I'd like to first share some words about Unstructured, and then I'll move on to the actual presentation. In short, our company's goal is to make it easy for organizations like yourselves with their unstructured data. So from small collections to massive enterprise scale streams of unstructured data. We have an open source library for doing so. That was our original claim to fame. And since its release back in 2022, it's been downloaded over 40 million times. Since then, we also need to eat. So we've also built a hosted managed commercial platform around document transformation at scale. And on that platform, we have more than 10,000 paying customers. Between the two, we're used by over 65,000 organizations worldwide. All right, so with that, let's go ahead and jump into today's topic, pushing the boundaries of document quality transformation. So in deciding how to frame today's talk, originally I was just going to focus on the more recent work we've been doing at Unstructured around document transformation quality. But as I traced the thread backward, looking for a good cutoff point, I realized the company's entire short 3-year history has been life at the edge. And the work we did at the beginning of the story was actually just as interesting as the work we're doing now. So I thought, hey, everyone loves a good come-up story. I'll share the whole ride. So also, if you're familiar with unstructured and/or rag, hopefully the wordplay here in the title is not lost on you. Rag here, of course, refers to retrieval augmented generation, which of course became the niche that drove Unstructured's open source library viral. So in thinking of a catchy opening title, quite wonderfully, I soon realized that Unstructured's rags to riches come-up story was also a rag to niches story as well. So, and believe it or not, this wordsmithing was not AI generated. I take full credit for it. So the underlying focus of today's talk is on what we at Unstructured have done over the years to push document transformation quality forward. But so that we're all on the same page, what is document transformation and why is it so important? Document transformation is the process of converting digital or paper documents from one format, structure, or medium to another for a new purpose, often to improve accessibility, searchability, compatibility with new systems, or to enable digital transformation. When Unstructured arrived on the scene back in 2022, document transformation was a pretty fragmented space. The lay of the land was that there were hundreds of these one-off open source libraries available for working, each with a single file format. And then there were a handful of the hyperscaler incumbents, Microsoft, Google, AWS, with commercial offerings of proprietary solutions for the top few most common file formats in business, although they're all mostly focused around PDFs. Meanwhile, the Unstructured founding team were all career veterans in the unstructured data space, and what united them was that they had really spent years banging their heads against the wall, solving the same problems project after project, ingesting the data from myriad file formats, normalizing the outputs, cleaning it, organizing it, labeling it, tagging it with metadata, and so on and so forth. And every project seemed to start with the same sort of overlap and all this boilerplate setup and processing to do before they could even get to the meaningful work. So they set out to change all of that. The Unstructured founding team aimed at creating a single library to unify hundreds of open source libraries in order to create a common interface for transforming any unstructured document regardless of its original format. It was a bold vision, and of course, cutting edge quality was paramount, but they were also going for coverage as well. So they were breaking from the paradigm of supporting a handful of file formats to now handling dozens of file formats with the same library. And of course, to make downstream processing easier, they also envisioned a universal file representation. So regardless of the input file format, the downstream file format would be in the same universal file format. And it was designed to be versatile to support any downstream use case. And of course, to make it even easier to retrieve the data and then subsequently store the transformed data, they envisioned building dozens of upstream and downstream data connectors to the common systems of record upstream and the common databases downstream. So in a nutshell, a single library to rule them all, a universal file representation, and cutting-edge document quality transform. A tall order. And did I mention that they wanted to give it away for free? The team executed, and in September of 2022, they launched all of that as an open source library, which made a splash, was well received by the community, and then something quite unexpected happened, something that would change Unstructured's trajectory forever. And that was ChatGPT was born. And with it, the LLM revolution. Less than 2 months later, in November 2022, OpenAI released ChatGPT. And with that, the LLM revolution was underway. Suddenly, overnight, large language models fundamentally reimagined what we could do with unstructured data. Organizations quickly realized that when they combined their private data with LLMs, these LLMs stood poised to offer immense business value. If only there were a good way to get all those business documents into a format that could be understood by large language models. And hopefully the cheekiness is not lost on you. We had just solved that problem with our open source. And so given we had the unstructured open source, to no surprise, went viral. Or actually to everyone's surprise, but in hindsight, of course. In terms of a feature set, the library fulfilled the vision it set out to achieve. Plus, it then tacked on built-in support for RAG to capitalize on the exploding RAG market. So coming back to this question of document transformation quality and the impact this had, of course, the library did bring to the table document transformation quality improvements for certain specific file types, such as upping the quality ante for an open source PDF parser. But its impact was sort of bigger than that. The library's release marked a sort of phase shift in thinking about unstructured data that fundamentally reshaped the space. And however, it's hard to actually quantify its impact specifically on transformation quality because its full impact can't simply be measured by just aggregating all the individual F1 score improvements made across the different file formats. If you think about it, the impact the open source library likely made most was in terms of the macro level of holistic completeness of data coverage organizations could now suddenly enjoy with their unstructured data strategies. So if you consider it from that lens of an organization's entire coverage of all their unstructured documents, prior to unstructured, their holistic F1 score, if you will, were probably pretty abysmal. I mean, the amount of development work to build a comprehensive in-house solution comparable to unstructured's was far more than most organizations were willing to invest. So they either had to settle for the small handful of file types supported by commercial providers, or else build a homegrown solution in which they supported the files that they most cared about and then only added new files as they needed. So that being the case, imagine all those missing holes in the unstructured data record if many file formats categorically aren't even supported in their unstructured data strategy. So that's that. Another major impact the unstructured open source library made was on transformation quality was yet another implicit one, and yet it involved the end-to-end impacts. A common step of the unstructured data transformation process is typically cleaning the data. With unstructured's universal file format and standardized ontology, it suddenly made it massively easier to clean documents at scale. Especially in the context of RAG, you don't want gibberish gunking up your limited context window, especially at the early time when the context windows were limited. So because the unstructured universal file format distinguishes document element types like headers, narrative text, footers, and so forth, you can suddenly now, with one line of code across thousands of documents, clean up all of those document footers, for example, which don't typically contain much substance that would be of interest for an LLM-based program. Or if you want to target tables specifically, the library makes that trivial to do so. And of course, you can actually quantitatively assess the impact of these cleaning operations on the overall effectiveness of RAG systems. And when we did, it was often quite significant, offering single-digit increases in overall F1 score percentages. So that's open source, that's its impact. But what about Unstructured's more recent developments? To understand a lot more of the recent focus at Unstructured in its research and development, we first need to take a closer look at another development that happened nearly 2 years after the release of the first commercial large language models. And that was the release of the first commercial vision language models, VLMs. And specifically, that was GPT-4o and Claude Sonnet. But why are VLMs so important? The best way to intuitively understand vision language models are that they are essentially large language models and large vision models that have been merged and aligned such that they share a common embedding space. But what does that mean? In effect, and for example, textual sequences containing the word cat from all the text-based training of the large language model will appear in the same general vector space as images of cat from the vision language model. So they've since been overlaid over each other. But bringing that to the document AI space, why is that important? Well, when a vision language model sees an image, it sees it semantically, or in terms of the text-based sequences, and visually, in terms of like the pixel pattern-based images, at the same time. And similarly, when it sees its text, it also sees it semantically and visually at the same time. And so it's sort of this synesthesia where, thanks to the power of attention and this shared embedding space, it's like seeing all the contextual associations of each word and visual object in the document but it's also seeing their adjacent connections in the embedding space to other similar words, other objects, all from its training data. So what this means is that as compared to the previous generation of the convolutional neural net style object detection models that we had implemented in our open source, which enabled us to draw probabilistic bounding boxes around sections of the documents that we call elements, and then categorize those elements and then do OCR in a following pass. Now suddenly we have a whole new class of model that actually sort of understands what it sees and the relationships between elements on the page. So as you can see, now things are starting to actually get really interesting. So with the VLM revolution, vision language models are no longer groping around the dark trying to draw bounding boxes around distinct elements on a page without really knowing what those elements are. Suddenly, these vision language models can now sort of perceive the document's contents, which is huge. Of course, this is how it goes. But when GPT-4o launched in May of 2024, it was only just a few months after years of trying, we surpassed the commercial market leaders in PDF processing with our OD OCR model. But then we quickly realized that we needed to sort of start from scratch and dive headfirst into this new territory of understanding and building strategies around these large closed source vision language models. But after some exciting initial experiments, we suddenly had a thought. Whereas with the previous generation of vision models, the CNN style architectures like the YOLO-X OD models, it was always a question of how do we improve document transformation? With this superpowered or these superpowered vision language models, suddenly for the first time, a new question popped into our mind. And that question was, can we possibly now solve document transformation? So with VLMs and that question, that's really where a lot of our most recent innovation work around document transformation started. And of course, the first order of business was tackling the challenge of building the best VLM parser on the market. And that, of course, started with choosing the best representation layer. So we actually went with a contrarian bet. While the industry scrambled to use Markdown or plain text to save on token count, after careful scrutiny and thinking about the long-term game of context windows increasing and so forth, we decided to go with the more verbose HTML. And our reason was that, and although we couldn't be 100% certain about this because they were closed source and proprietary models, we had strong reason to believe that these closed source VLMs had been trained on extremely large data sets of HTML and UI screenshot pairs. This led us to the hypothesis that by choosing HTML as our output representation layer, the large latent space coverage owing to such a data set would improve the model's inference ability to convert difficult documents. We also suspected that this would help lower its inference cognitive load by not having to translate its output into a non-native format that was not represented in its training set, such as Markdown. It was all theory and speculation until the results started to show that it seemed like we were on the right track. And of course, HTML can easily be downscaled to Markdown. So if you do want to use Markdown in your applications, that's all possible easily as a post-transformation step. And of course, there were a few other perks that came with the choice for HTML as well. Superior layout support, native renderability, enhanced stylization capabilities, as you'll see in just a moment. But there is another problem. HTML is a very expressive language, yes, but the full language specification includes a wide range of language features that are unrelated to representing documents. After all, it's the language of the entire World Wide Web. And the range of ways to represent the same content in HTML is actually pretty vast. So we realized to build a production-grade product, if we were going to go with HTML, we need a way to ensure the consistency and reliability. The next novel approach we chose was in constraining the HTML vocabulary to a small subset, and also at the same time, and in so doing, to create a more robust document element ontology that could represent documents in very high fidelity, approaching their original likeness. And as an example of that, I've prepared a short demo. And so as you can see here, this is a Microsoft 10K report. And you can see the source document on the left, as well as our rendered HTML on the right. And of course, you will notice that it is extremely high fidelity. It's preserving roughly the same structure as the textual content, even checkboxes. We've even stylized it. This, of course, is not necessary. The representation layer is totally up to you. So if you wanted to brand this with your company colors and so on, you can do so. Similarly, you can, as you can see, like it's sort of stack ranking it everything by element. But if you wanted to add, CSS flexbox styles to get it sort of more resembling the original document, that's all just a styling preference. So in any case, this is a sort of good example of what you can get with the VLM output. And just to give you a quick view of what the actual element ontology looks like in practice, if you see the source code HTML side by side, you can see in this class field, you can see sort of what the element ontology actually looks like for a document like this. So everything from checkboxes, form field values, titles, tables, and so on. So ultimately, at the time we released our ETL platform in December of 2024, our internal benchmarks showed that our transformation performance was basically unsurpassed in the market, despite the fact that at that time, all of our competitors had also incorporated VLM-based strategies, and they were using the same models, yet we were still outperforming them. So clearly, our approach was working. Okay, amazing. So we've developed this powerhouse of a VLM parser that in our average benchmarks was basically outperforming our previous generation by around 10 percentage points or so. But that still only takes us to around 95%. And if you're wondering what CCT means, that stands for clean concatenated text. It's one of our sort of standard metrics that we measure at Unstructured. We also benchmark our competitors by this, and it's basically the idea is that if you read a document in the standard reading order, so from left to right, top to bottom, then the clean concatenated text version of the document would be essentially the order of words that you encounter in that process separated by a white space character. So it might seem simple and basic, but it's actually a very compelling way to sort of determine accuracy of a parse. So going back to, if you remember our previous question, we asked ourselves, like, how do we actually solve document transformation? I would say like mid 90s is not solving document transformation. How do we actually go all the way up to the high 90s territory, ideally approaching 99%, 100? So with that goal in mind, we're now engaged with not just building the smartest VLM parser, but the smartest parser, period. We've called it different names. The market's actually called it different names as well. We actually originally branded it synthetic parsing. The market sort of landed on agentic parsing. But the idea is the same. Given that you now have a fairly robust LLM-based reasoning models, we have a suite of high-performance object detection models that can detect layouts within a document, VLMs, and of course, no shortage of frameworks for building agentic systems. How can we build a parsing engine that effectively solves document transformation? So our R&D team is still pioneering this work, but we do know that what some of the ingredients of the solution look like. So dynamic routing, that can be at the page level all the way down to the element level. So sending certain sections of the document potentially to specialized prompts and specialized VLMs specifically for that. Self-examination, iterative refinement, so it can ask itself questions. Does this parse make sense given the context? Should I reprocess this document with different parameters? And then, of course, consistency validation. Are there inconsistencies with ambiguous conflict resolution, suggesting that it needs an additional pass or some sort of alternative approach? And of course, if you want to go further, you also have to increase the fidelity of the representation, expand the element ontology. You probably want to look into more complete evaluation metrics and so forth, but you sort of get the idea there. So in terms of what comes next, we have a few things, few rods in the iron, or irons in the fire, so to speak. We are also improving the quality of transformation in terms of understanding the documents, adding custom metadata enrichments, structured data extraction. We actually have a webinar on that next week if you'd like to deep dive into that topic. But all of this is to basically increase the quality of the transform in various sort of use cases. And of course, one of our focuses is delivering that data to agents, so improving the quality of document transformation, both initiated and brokered by agents, as well as the transform data being securely delivered to agents. And finally, we're expanding the scope of files that we serve from traditional text-based documents to audio and video artifacts as well. So closing the gap on even more unstructured data sources, and pioneering our rigorous quality standards into those new frontiers as well. And with that, we've made it through. So just to recap on the journey we've taken, I've basically walked you through sort of the vision of our open source library going back all the way to our founding days, all the way to pioneering a novel VLM parsing strategy, all the way to agentic parsing and beyond. And at every step of the way, just sort of highlighting our innovations that we brought forward and focus on pushing the boundaries of document transformation quality. So if you'd like to learn more about table extraction or many other topics, feel free to check out our past webinars. And if you'd like to learn more about what we're doing in the unstructured to structured data extraction space, please join us next week as we drill down into that topic. And with that, I will, oops, I forgot to advance the slide, sorry. You can see the recap there. And then now we will take some questions.
Thank you, Daniel. We have some questions that were pre-submitted to us through the signups, but also we have a couple of questions that came in live while you were presenting. So let's start with the ones that came in live, and then we'll move on to the pre-submitted questions. So the first question is, what are the most common types of files you're working on? Business docs, presentations, long reports, or customer databases, or something else?
Yeah, it's a great question. I would say we see definitely all of that. It's not really the types of files that we're working on, it's what our customers are working on. And by far the most common is PDFs. That's sort of like the business gold. But we see everything. And yes, everything from business docs, presentations, long reports. I mean, Excel files, CSV. There's something called like the Big Ten file formats, and it's basically PDFs, PowerPoints, Excel, CSVs, DocX, HTML, and I might be missing one or two, but I think that gives you a pretty good idea.
Yeah, and the second question is actually very is related to the first one. Any intention to move into technical documents slash data, for example, 3D CAD files or PDFs with technical drawings?
Yeah, we've absolutely seen this. I would say it's on the horizon. We don't have like any immediate plans to tackle that challenge specifically, but it's come up many times in the past. The challenge with CAD and all those, like that's an example of needing sort of like specialized models for parsing that. And we also need a totally new sort of like ontology for representing that information. So it's not that we won't support it; it's just a matter of when. But if it's important to you, of course, we can definitely prioritize things on the roadmap if it's sort of a big enough use case for the market.
Right. Let's move on to some of the questions that we have pre-submitted. And the first one is, in practice, enterprises rarely deal with just one format at a time. How should they think about evaluating accuracy across blended documents that mix PDFs, emails, spreadsheets, and images? So I think I can take this one. If we're talking about evaluating the data processing quality, then that would require either manual effort or labeling data first, understanding the metrics that you want to use, like CCT or token accuracy, and then you can compare different parsers. If the question was about the RAG evaluation, that it's a whole other can of forms with different aspects to it. Like, are you evaluating retrieval? Are you evaluating the accuracy of the LLM answers? Is there something else that you are evaluating? And so since we're focusing in this webinar on transformation, the RAG side of it is a little bit outside of the scope. I hope this answers that question. Now, the next question is about legacy publishing formats like InDesign, Quark, Express, and Publisher, which also contain critical data that often goes unseen. Do you see a role for tools that can unlock and structure these design-centric files alongside the Office formats that you've highlighted? Can you answer this one, Daniel?
Yeah, sure. I mean, it's the same sort of idea as the previous CAD related question. Like, we definitely see business value. It's just a sort of question of when will we get to that format. But yeah, all business sort of documents are within sort of the range and the scope for the future. And I think we're at time, Maria.
Yes, we are at time. Unfortunately, we don't have more time to answer more questions, But thank you everybody so much for joining us, for engaging with us through questions and in the chat. We're going to send you the webinar recording, and we would love to see you join our upcoming webinars. The next one is going to be next week, and it's going to focus on structured data extraction. Thank you for joining once again. Would love to see you again. Bye.
Thanks, everyone.